Welcome everybody, I'm delighted to be here. That's me, that's a little bit about me. It's my first webinar, so please forgive me if I get any of the etiquette wrong. I've pretty much worked for contractors most of my career. I've programmed projects, I've prepared and negotiated claims, I've given expert evidence in adjudications, arbitrations, litigations, both in the UK and internationally. And as Nina very kindly said, I was part of the drafting panel for the SCL programming protocol. So I'm probably reasonably qualified to talk to you today on programming. I'm going to run through today a short history of programming. I think this is quite important because the understanding of the history of programming and how it's developed gives understanding of where we are today with programming. And you can really then see where it's going and how it's changing. And it's definitely a rapidly changing area of the management of construction projects. One thing is for certain, that very few contract drafters fully understand programming or program analysis. And most contracts are pretty poorly drafted when it comes down to program requirements. And secondly, few in the industry really understand programming and how the programs work. And I'm one of the many who don't really understand. I think the algorithms in the programming packages are quite complicated, and they don't always give you the answer that you expect to get. That's the business that I'm working for at the moment. Morsson Pyper, we provide executive services to the construction sector, and we aim for prevention rather than cure. I think most consultancies support clients in dealing with their existing problems and issues, things that have already arisen. What we try to do is really help them with prevention, and we act at board level. So most of our team have been sitting on the boards of major contractors across the UK. I've got limited time today, about 35 minutes in total. I think Nina will step in and tell me when I'm nearing my full time. And I've got about 30 slides to go through with you, so let's crack on with them. This is a slide that I've used on a number of occasions: engineering as a science, QSing as an art, and programming as a mythology. So for an engineering, it's either right and it stands up, or it's wrong and it fails, and that's a science. QSing is more of an art. If you get a good QS, they can use artistic flair to increase the return on projects for contractors particularly. And programming is a mythology. It requires looking into the future. It's fortune telling. A program is really just someone's guess as to what might happen on the project in the future. So here's another slide I've used on a number of occasions. It's the slide that shows, and a number of you will probably have seen this before, it's a slide that shows successful project management. And successful project management is a balance between time, quality, and cost. Time is the most important of the three. If you lose time on a modern contract, then you will lose cost. And quality and scope are usually governed by the contract. So 6 things really I want you to take away from today about programming. Programming is an essential part of managing a contract and project complete on time. It's the primary function of programming is to manage the time, and for the claims consultants, this may surprise you, it's not to analyse the delays. Programs should be followed and used by the contractors as a management tool. Programs must be updated regularly, and programs should always show a realistic and achievable sequence to completion. The program is a tool that's owned, managed, prepared, and used by the contractor for the contractor. The employer's interest in the program is really just to help the employer understand that the contractor knows what he is doing, that he has covered all the works, and that he is going to make regular progress on the job to completion. So the history lesson. I'm going to start going back in history over 5,000 years to the Great Pyramids of Giza. This was the pyramids were an amazing construction project. It's the world's first and oldest surviving construction project. Over 2 million blocks were placed in each pyramid, each weighing over 2 tons. Thousands of skilled workers working in 4 teams, 1 on each face, over a 20-year construction program period. That would be unrealistic in the current market. It must have required sophisticated project management skills to find, cut, transport and place all of those blocks without the use of modern technology. And it's the origins really of construction project management. But of the 3 essentials for project management, it had quality, but there was no control over time or costs, and probably because the pharaohs at the time had an abundance of money and weren't concerned over the costs. So I'm going to move you forward 4,000 years now to the Taj Mahal in India, and the same problems really existed then. It was built in 1632. It's surprisingly small, which those of you who have visited will realize. It looks a lot bigger in the photographs. It's only 55 meters by 55 meters. It took 22 years to build. It was built by Shah Jahan and involved many thousands of workers. He built it as a mausoleum for his wife, so she had to wait 22 years for her body to be put to rest. And again, of the 3 essentials, it had quality, but there was no control over time or cost. Now, Shah Jahan paid the ultimate price for that in the end, when he threatened to build an identical Taj on the south side of the river in black marble. He was murdered by his sons because the cost, he would be spending all of their inheritance. The costs would be too much, even in that time. So costs were starting to get a little bit more important then. But still, managing construction projects, programs, and controlling the costs is not something that has come about over time, really. The modern programming owes its roots probably to the 18th century, and the biographer Joseph Priestley and William Playfair. They were the 2 who came up with the first tools that we use today for programming, which is line bars, histograms, and pie charts. We'll have to move forward another 200 years, really, to the 20th century before we started to manage construction projects. The program tools we use today for managing time in construction projects were only really developed in the early 1900s. The first recorded tool for a construction project time management was called a harmonogram, and it was designed by Karol Adamaki, a Polish professor. And that was round about the late 1890s. He was Polish and he published his research in Polish, so it wasn't universally accepted at the time. The idea, however, was picked up by Henry Gantt in the early 1920s, and he produced a visual tool for showing program and progress called a Gantt chart, and that's still used a lot today. Basically, he came up with 3 simple charts to show the intended program for the works, and then he produced bars showing which were colored in to show the progress to date. Note that this was not called a program, it was called a chart, a Gantt chart, because it shows an as-built record, so it's not showing particularly where the job's going, it's showing the historical performance on the project. Henry Gantt put the dates across the top and the activities down the side. If you look back at Adamaki's research, the Polish professor, he had it the other way around. So if he'd written his report in England, maybe today we would, in English, maybe today we would have programs with the dates down the side and the activities across the top. The first recorded project to use programming to help with the construction was the Hoover Dam project in America in 1931, and they used a series of Gantt charts to lay out the program that they intended to work and to monitor the progress, and that was used to help improve projects in the future. The Gantt chart was only really adopted for use on construction projects after that project had finished in 1956, when it was used for the USA highways work in America. So programming of construction projects is actually younger than I am, which makes me feel very old now. The problem with the Gantt chart is that it was just a graphical interface. It showed the progress, but it didn't really help to manage the progress. And it didn't show the interrelationship between activities. So it was no good really at improving performance. It was just used for monitoring. So the next major innovation was brought about by scientists and mathematicians in 1958, and it was the development of PERT. PERT stands for the Program Evaluation Review Technique, and it was developed by the US Navy's Special Projects Office, the aerospace company Lockheed Missile Systems, and the consultancy firm Booz Hamilton Allen. Effectively, this was the invention of critical path. PERT was used in 1958 on the Trident missile project. It was credited with knocking over 2 years off the construction period, which was essential for the Americans at the time because of the Cuban crisis. The drivers for PERT were political, not commercial. So it drove the program, but it didn't really help to manage the costs very much. It was designed to tackle the interrelationship between the various activities on the program. They used it to control over 3,000 contractors on the project, and the project finished on time. The calculations at that stage were carried out by huge IBM mainframe computers that were spread over 17 warehouses. So it just shows what was needed to manage a program in those days. As the development of programming continued, the activity online method was introduced, where each operation was governed by 4 bits of data: a start date, a finish date, an event number, and some float. And with that, you had a forward pass and a backward pass, and the float was calculated, and effectively the critical path could be determined. But this couldn't be used to improve progress. Again, so this research was picked up in 1958 by Morgan R. Walker of DuPont and James E. Kelly of Remington, and they developed a tool for commercial use that became known as the critical path method. So the term was in fact developed by the PERT team, but it was adopted by Walker and Kelly in their research. The activity on node diagram was a further development of this. And the activity on node diagram held 8 bits of information on every activity. So it held an earliest start date, an earliest finish date, a latest start date, a latest finish date, a duration, a float, and the activity number. And the idea was that each activity was then linked to a preceding and future activity. And this has developed into what was known as CPM. CPM stands for Critical Path Method, but it has been later changed to Critical Path Management and Critical Path Programming. Early CPM had its limitations. It did not consider non-critical activities that could introduce risks to the project, such as labour issues. It did not take account of the fact that the critical path may change during the progress of the project's duration. It was difficult to manage manually and generally required substantial computers with IT professionals who did not understand the construction process. It was difficult to appreciate the alternatives for improving the critical path, and it was expensive and required months of training and computer knowledge to carry out. But the technical side of programming continued to develop through into the 1970s, and an Israeli scientist, Elijah Goldblatt, wrote a theory of constraints, which was that a system can never be better than its weakest parts. So the improvement of a project and its program depends on the identification of the constraints and their mitigation. Effectively, this was re-looking at the critical path once it had been assessed to identify the weak parts, and then looking at improvements to these areas, which is known today as risk management. Really, the programming we know today only came about in the late 1970s, early 1980s with the PC revolution. What the PCs did is it enabled the calculations that were necessary to carry out the analysis of programs to be carried out on a computer at a price that was affordable for most construction projects. And with the development of the personal computer came the development of certain packages to help with the programming of construction projects. The earlier entrants into the market were Primavera, Microsoft Project, and Asta. And these have continued to develop over the progress of programming. Primavera has become known as the major project's client's choice of programming. Asta probably has become known as the contractor's choice of programming software, and MS Project is the software that's used on smaller construction projects. With the development of the computer packages came new techniques such as resource balancing. So the computers developed to add resources against the programmed items and costs, and then calculate the most efficient use of resources across the project. And it developed other systems such as crashing the resources, increasing resources in a certain area so that activities could be completed quicker. Initially, the critical path management looked just at the activities on site, but over recent years that has been extended further into design, procurement, manufacture, delivery, and managing subcontractors' works on site, all in one master program, and all at different levels. Really, the first major project to use one of the major packages across the whole project was the Hong Kong Airport and Mass Transit Railways in the 1990s. They chose to use Primavera software by the whole of the management team for all aspects of the project. So everybody used it. The clients, the contractors, the subcontractors, the suppliers were all working to the same program, eliminating many of the risks that had beset previous major projects. It's the first time that I know of that a major project had managed the resources across all of the different contractors against all of the different designs. And it was necessary, and it worked, and Hong Kong was handed over on the due date. And really just finishing off the history, again, the whole of the Olympics project was managed using Primavera software across the board. And despite early concerns that the industry wasn't up to finishing such a major project on time, I think the record of success at the end of the day is evident. It was finished on time and on budget, and most of that is down to the programming and the way that the project was programmed and managed. Problems today exist with the software. The packages are not intuitive to use. The printouts that you get for them are not easy to understand or follow by the site team. Most programs contain errors, and the errors are difficult to spot. You've got missing links, wrong links, too many links, wrong outputs. And looking at programs, it's difficult to spot if the programmer has used the wrong logic or has missed activities. Packages tend to be mostly operated by those with programming computer skills and not by the engineers with the construction and output skills, and there's a disconnect between the two. Programs can now run to many thousands of items and many hundreds of pages, which make them difficult to follow and read. The costs of licenses means that not everybody on site has a copy of the programming software, and therefore they're reliant on the programmers producing the information that they need, and things such as printouts are actually quite difficult on a number of the packages. Many of the packages are not specific to construction. Primavera for a while did go along the P3C, which was a construction edition of Primavera, but the business was sold and they just have a projects programming software now that will suit construction, but all other projects as well. So where's programming going in the future? I predict that very soon programs will be linked to the CAD and BIM packages. The databases are growing all the time, but the databases will have thousands of outputs, thousands of alternative methods of construction, and will automatically generate programs as the projects are drawn into the BIM package. They'll also automatically generate a price. Contractors will then tender on the basis of what improvements they can make to the standard model. Programs will become more graphical. Site engineers will carry around devices which show on the screen exactly what work they are going to build on a daily basis, and the devices will pick up what work was completed the day before and automatically produce as-built programs. Eventually, the programming software will automatically assess extensions of time. So yes, I believe that this may be a dying profession, and the risk of disruption, as they say in Silicon Valley, is high for programming of construction projects in the future. So what is a program? I used to say a program is a planned series of future events, but it's developed in construction. So now, when you're talking about a program in construction, you're talking about a tool that divides the work into a series of activities, each with a duration and logic links to preceding and succeeding activities, forming a network of activities. It can be provided in many different formats, from the Gantt or bar chart to line of balance chart, all the way through to a time chainage chart. Each activity on your program should have the activity on node 8 key bits of information. So for each activity, you should know the earliest start date, the earliest finish date, the latest start date, the latest finish date, the float, the duration. Programs, by their very nature, are prospective. They look into the future, not into the past. There is no such thing as an as-built program. It's an as-built record. It's a fact. Similarly, there's no such thing as forward planning. All planning is looking forward. So it is important for contractors to understand this, as it's one of the key principles behind delay analysis. Let me look at the logic of best practice programming. The logic follows these 10 simple points, really. Good projects require good contractors. Good contractors need good management. Good management requires a good program. Good programs cover all the works, are resourced, priced and used. If an employer event delays the works, a good contractor needs to reprogram the works immediately. The contractor should always be working to the most efficient program. This can only happen if the employer's team award the extension of time immediately. If not, the contractor is almost forced to accelerate. If the extension of time is awarded immediately, the project remains a good project to completion. If a contractor event delays the program, the contractor should consider resequencing and acceleration. The contractor should always be working to a realistic program to completion. And remember, the program belongs to the contractor. It's there to help the contractor build the project in a logical and managed way. The sequencing and timing is therefore up to the contractor to choose. The contractor can change this as often as he likes. He's not normally bound to stick by the original program or baseline program. However, he must comply with the requirements of the contract. Any of the client's new and post-contract requirements with regards to the program may constitute a variation or change for which the contractor would be entitled to be paid. Now, every contract has risks, and therefore every program has risks. The weather can be too hot, too cold, too windy, too wet. The labour, materials, plant, subcontractor availability is always questionable. There's quality of management of labour and subcontractors. Their outputs are achievable. What outputs are achievable? There's failure of subcontractors. There's health and safety risks, economic risks, political risks, unforeseen and unaccepted circumstances, ground conditions, acts of gods, and design and specification uncertainty, and many, many more risks. Contractors cannot be expected to program all of those risks into the project at the beginning of the job. If they did, they would not win the projects. So with all of those risks, it's ridiculous for the industry to place so much emphasis on the contractor's original baseline program. I really don't know how contractors can be expected to manage all of those risks and allow for them all within the first 14 days of the award of contract. It can't. Programs have to be live documents. They have to be updated on at least a monthly basis. Some contracts realise this and make it a standard contractual requirement. Others have very little in the contract about programming. I want to talk about prospective and theoretical. You'll hear a lot in programming about prospective and retrospective programmings. The definition of prospective is expected to be the specified thing in the future or likely to happen at a future date. The definition of retrospective is looking back on or dealing with past events. Most contracts are not designed for a retrospective programming assessment. Most contractors, however, allow for a retrospective assessment of the costs, and the difference between that has to be appreciated by the site team. You need to prospectively program and in most cases retrospectively assess the costs. A program is not a factual document. It is not an assessment of the anticipated sequence. It is an assessment of the anticipated sequence and durations and the contract that the contractor will aim to achieve based on a quick review of the works. A prospective analysis is therefore one that is carried out before the works have been completed, looking at what might happen or what is intended to happen at that point in time. A retrospective is one that is carried out after the works have been completed with the benefit of hindsight and the as-built program or the as-built knowledge. A prospective analysis, therefore, is totally theoretical, whilst a respective analysis is to some extent based on the facts. It is possible to carry out a prospective analysis retrospectively. That is putting yourselves in the shoes of the programmer at the time with just the knowledge that the programmer would have had at that time, and ignore what has happened in fact after that date. Prospective analysis should be based on achievable outputs and projected available resources. And this can be based on a database of knowledge or the management team's experience of similar projects. Courts, however, deal with facts, and there's a tendency for the courts to place more emphasis on retrospective analysis than a prospective analysis. This may change in the future, because I think there's becoming an understanding by the courts and the tribunals that if the contract requires prospective analysis, the tribunal should review on the basis of a prospective analysis. I've touched on this briefly, but critical path is important. The critical path is the sequence of activities with the least float, or in fact, the activities that have zero float. So why is the critical path important? It determines the anticipated earliest completion date for the project. It determines the anticipated earliest and latest completion dates for individual activities. It calculates the float, it identifies which activities are important to the completion of the project, and it identifies areas of risk. It identifies where actions should be taken to reduce the project duration or to recover delays. Now, there are a number of different types of programs that you'll find on any contract, and the ones on the left here are ones that really are required by the contractor to share with the employer. So we start off with the tender program. The estimating team decide at the beginning on how they will tackle the project. The tender program is prepared by the programmer who has less technical knowledge of the project. It's compiled under the time restraints of the tender process, and they won't get it right first time. The contract outputs will be based on similar projects that they have constructed in the past, but may well be based on just an individual's expertise. The contractor should then look at the critical path of the project and use his experience to analyse this to see if crashing resources, pruning activities, balancing resources will actually improve the programme. By the time the tender is submitted, the programme is assumed to be the most efficient programme that the contractor can prepare at that point in time, bearing in mind the circumstances under which it was prepared. Less weight should be given to the tender programme in reviews than should be given to subsequent programmes. The next programme that's produced by the contractor would be the baseline or accepted programme. Most contracts require this to be produced in a period of around about 4 weeks following the award of contract. This is the main programme which the contract administrator will monitor the works against to see if the contractor has understood the contractual requirements. It is good practice and often a contractual requirement to show the contractual critical path on the baseline programme or the accepted programme. The contractor will tell the contractor how much information, the contract will tell the contractor how much information is to be required to be shown on the baseline programme. This may be different in different contracts. The next programme is the updated progress comparison and the updated programme new baseline. Now these are two separate programmes and all too often I see them confused and conflated. The update progress comparison, the first month after the into the project, you will take the existing baseline programme and you will mark up the progress to date as a progress comparison. This update gives a comparison between the previous baseline and the works completed in the period, and reasons can be recorded against any divergence from the original programme. If this is done contemporaneously, then significant weight can be given to this by the tribunal. It may be used to analyse the cause of delays over the month. So the updated progress comparison will look at the cause of the delays over the month. Once you've completed that comparison at the end of the month, you should go on to another comparison, which is a new baseline programme. The new baseline programme will take account of any new knowledge you have, any progress that you've made during the previous month. The contractor can decide to resequence the works, can accelerate the works if necessary, can change the logic, can correct errors in the programme. And you'll have a new baseline programme. This programme may be used with a little analysis for the assessment of the effect of the delays over the previous month and show an entitlement to an extension of time. So the updated progress comparison will show the cause of the delays. The new baseline will show the effect of the delays, and it's the cause and effect that will give you an entitlement to money should you seek to recover it at the end of the day. The as-built programme or as-built record is something that should just drop out of the other programming. There are various other programmes that the contractor will have, the short-term programme, the internal target programme, design programmes, all aimed really at just helping the contractor manage the works. And very quickly, I'm going to look at some of the requirements in contracts for programme. In the UK, the old JCT and ICE contracts just had one requirement: the contractor shall produce a programme. The new FIDIC and the new NEC contract have a lot more requirements for the programme that's to be prepared by the contractor as the baseline programme. And here I've listed 19 requirements in the contract that must be recorded in the programme by the contractor when he prepares it at the beginning of the project. That's 1 to 9 and then 10 to 19. This is good. These are good requirements, but there's still other things that I think ought to be shown on the programme. The design should be shown on the programme. The approvals should be shown on the programme. Information required programme, a procurement programme, each supplier and subcontractor, material deliveries, material order programme, commissioning, fitting out. All of these things really need to be shown on the baseline programme. There are two things there that I'm not so happy should be shown on the baseline programme from the contractor's perspective, and that's the provision of float and the provision of time risk allowances. Particularly the provision of time risk allowances. These are the contractor's assessment of what is required for his risk, and it's really down to the contractor what risk assessments he makes. I'm going to move now to acceptance of the programme, and I'm using the NEC contract again as an example, but most contractors follow a similar sort of requirement. The contractor will put his programme in and the client either accepts or rejects it within a 2-week period. There are limited reasons normally for the rejection of a program, and in the NEC, the reasons for rejection are the plan is not practicable, the plan is not realistic, it does not show the information which the contract requires, and it does not comply with the works information. The first two, practicability and realism, are really matters for the contractor. Whilst the employer can raise them, if the contractor still believes they're practicable and realistic, then he should stick with his program. If the program does not show the information that the contract requires and does not comply with the works information, then that is wrong, and the contractor should make the alterations to this. It's very, very important under most contracts to have an agreed program, and I think it's important enough to refer to the DRB, refer to adjudication, even to arbitration, in order that the project is working to an agreed program. What happens if the PM does not approve the program? Well, under the NEC 4, there's a new procedure which is working its way into FIDIC as well, which is deemed acceptance. And I quite like this. The problem with working with an unapproved program is that the contract requires all comparisons to be made against the last approved program. And it forces bad practice on the contractor, with the contractor producing maybe a program for working to and a different program for the management of the project. And this can get really confusing. So under NEC 4, the program, if the program is not rejected on one of the approved grounds, it is deemed to be accepted. When should an extension of time be awarded? Most contractors require the extension of time to be awarded at the time of the delaying event, or as close as possible to the time of the delaying event. In the SEL protocol, we said the contemporaneous submission and assessment of extension of time claims is elevated to a core principle. This allows appropriate mitigation measures to be considered by the project participants so as to limit the impact of the delay event. It also provides the employer and the contractor with clarity around the completion date so that they can understand their risks and obligations and act accordingly. In Vivian Ramsey's book, he said it is clearly desirable that when possible, an extension of time should be granted to a date in the future so that the contractor can plan the work accordingly. Now, some contractors require the contractor to apply for an extension of time. Some contracts require the employer or contract administrator to determine without an application from the contractor. Some require the employer contract administrator to determine prospectively only. And some contracts will allow for a retrospective evaluation. Few contracts will allow a retrospective review to reduce a previously awarded time. I think this is all very sensible. I think the sooner the contractor knows the revised completion date, the better. If the extension of time is not awarded at the time, the contractor is theoretically forced to accelerate. The contractor has to look again at its updated program and effectively look at how this can be accelerated to complete the works by the completion date. This can lead to uneconomic working, a greater risk if the works continue to change. It's not the most efficient way of working to completion and can lead to greater future problems. On my last slide, I want to look at the various delay analysis techniques. And I've included here a chart that's available in the SCL protocol, but it just lists out 6 of the primary techniques that are used for analysing delay. The first one on that list is impacted as planned analysis. Now, the type of analysis here is cause and effect. So the cause is established and then you look for the effect. The other way is where you look at the effect. It's a 30-week delay, what has caused it. So this is the cause and effect is looking at the cause and then the effect. We've listed here whether the critical path is determined prospectively, contemporaneously or retrospectively, and whether the delay impact is determined prospectively or retrospectively. So the impacted as planned analysis has come in for a lot of criticism in the past, but is actually a good method of analysis if you have a contract that is predominantly following the program and you don't have a lot of other programming information. It's relatively quick to prepare and can be relatively easy to demonstrate. Time impact analysis is really a little bit along the way that I have been suggesting today that programs should run. True time impact analysis, actually, for each delaying event, it requires the program to be updated to just before that event, and then the event put in, and using the existing program logic, the final date to be calculated. Most commentators will say that this is the best way of managing a project. True time impact analysis requires so much programming time, and rarely is that time there or information there in order to allow that to be carried out properly. The next one on the list is the time slice windows analysis. This looks at the effect and then determines the cause. Again, it's done contemporaneously, but this time the delay impact is determined with a view to what has actually happened. The last three are more retrospective, as planned versus as built window analysis, longest path, and collapsed as built analysis, all rely on some level of as built program data, by which time really the extension of time hasn't been awarded in due time to enable the contractor to correct the delays or take account of those delays. So we're looking at really the mythical situations again. Okay, that about wraps it up.
First question comes from Kareem. What do you mean by provision of the float, and how do we do it? And similarly, what do you mean by risk allowance, and how do we do that?
Okay, float is something that is worked out by the programming packages. What happens is the programming will add the durations of all the activities together and come up with the critical path. Items that aren't on the critical path will have float. And the float effectively means that they can take longer to complete those items than items without float. And therefore they won't affect the overall completion date. So items that don't have float can be changed and moved without affecting the overall completion date. Items with zero float are on the critical path, and therefore any delay on items on the critical path will affect the overall contract completion date. Okay, you will see on one of the slides that the contractor has to allow for risks in the program. So he does that in two different ways, really. He adjusts the allowances that he puts in for the outputs to allow for the risk within those outputs, or he can put a separate item in there for risk. If you put a risk item in there, in a number of contracts, you have to declare the risk items that you put in your program. So what has happened over the last few years is the contractors are saying, well, rather than the output being X meters of concrete per hour, I'm just going to add a little bit to that allowance, which will cover me for risk. So rather than 10 days for concreting during the winter, I'm going to allow 13 days for concreting during the winter. And only and the risk will be part of the allowance that's within the program.
Next question comes from Mustafa, who asks, can time impact analysis be carried out retrospectively?
The answer is yes, it can. But it depends what you're looking at. If you're looking at the claim at the end of the day, so you're at the end of the project, you can certainly go back and carry out a time impact analysis retrospectively. Generally, if you're doing it retrospectively, it's best to take on board the true facts. So you will know retrospectively, you will know what the facts are. So you will take it up to that point in time and work with the real facts. It is possible to do it on a prospective basis, as I said in the talk. So you can do the time impact analysis. You can come up to your event and just use the information that the programmer would have had at that time, providing you're very clear in what you're doing. So I think with delay analysis, what you have to be doing is be very clear and set out how you have analysed it and what you have done.
Okay, next question comes from Tahir, who asks, how important is it to input the material and resources into the programme from a cost management perspective?
Well, that's a good question. If you, from a contractor's point of view, if you use the big packages such as Primavera and you use it properly and you put all your time and all your resources in, you will build a good database that will improve the performance of the business overall. It also helps with resource balancing, and therefore you get a better, if you're inputting your resources and your against the time, the answers that you will get will be better at the end of the day. However, one of the problems that most contractors have is they don't always know the resources that they will be using, because a lot of their works are subcontracted, and to input resources into the program would mean getting hold of subcontractors' resources as well, and often that's not so easy. So if you can do it, you're getting better quality information and a better result at the end of the day, but it's the ability to do it that is always difficult.
Question from Awais, I hope I pronounced that right. Do we need to approve the extension of time even if the contractor is delaying the work? If yes, what if the contractor is continuously delaying the work?
Yes, you need to approve the extension of time, even if the contractor is delaying the work, because it's for the good of the contract. So if you don't, if the employer is delaying the work, he needs to accept it and issue the extension of time. If you don't, because you believe the contractor is delaying the work, you're heading towards a dispute at the end of the day. Concurrency is a very difficult topic to look at and would probably warrant a whole talk all on its own. But if the employer and the contractor are delaying the work at the same time, you will end up with a concurrent delay. But from the employer's perspective, my recommendation would be, if you have introduced something that has delayed the work, you award the time for that delay. You can look at the cost situation afterwards, but let the program, give the contractor the opportunity to reprogram the works to a completion date.
Thanks again to Keith for presenting the session today, and thank you to everybody for joining us.